Hello and welcome to the new video of Standard 10 Science Chapter 10. So in last video we have discussed about the image formation in convex mirror and the uses of convex mirror. Okay. So now next theory, which is 10.2.3, which is sign convention for reflection by spherical mirrors. While dealing with the reflection of light by spherical mirrors, we shall follow a set of sign conventions called the new Cartesian sign convention. In this convention, the pole P of the mirror is taken as the origin, the principal axis of the mirror is taken as the x-axis of the coordinate system. The conventions are as follows. Okay, so here what happened, for example, this is our one mirror, this is our pole P. Okay, this is x and this is x dash. Okay, so you can consider it as a number line. Okay, this is the number line, this is 0, which is pole P. These are positive numbers and these are negative numbers. Now first, the object is always placed to the left of the mirror. This implies that the light from the object falls on the mirror from the left hand side. Okay, in every figure we have seen that whether the lens is concave mirror or convex mirror, all the objects we have placed always to the left side. Okay, all distances parallel to the principal axis are measured from the pole of the mirror. Okay, all the distances are mold from pole P. So this pole P we will consider at a 0 point, and we have to measure the distance from this point only. All the distance measured to the right of the origin are taken as positive, while those measured to the left of the origin are taken as negative. Okay, as in number line we have seen that this is our number line, so right we will get positive values and next and left we will get negative values. Okay, so every time when we place our object to the left side, then that object is, the distance of that object will be in negative. Then distances measured perpendicular to and above the principal axis are taken as positive, whereas below the principal axis are taken as negative. Okay, so this is the lens, our mirror. Yes, let's take this is as our pole point P. Okay. Here, so this is the height of our object, so it is upward, then we will take height as a positive, but the image are inverted, so this we will take as a negative. The new Cartesian sign convention described above is illustrated in figure 10.9 for your reference. These sign conventions are applied to obtain the mirror formula and solve related numerical problems. Okay, as you can see here, the height is upward, height is downward, so it will be negative. This distance will be negative, this distance will be positive, and this is the direction of incident ray, and all the distance will be measured from this pole point P. Now we will solve some numericals. For solving numericals we need to find a formula. So 10.2.4 mirror formula and magnification. In a spherical mirror, the distance of the object from its pole is called the object distance. Okay, at whichever distance our object is placed from pole, then that distance is called our object distance. The distance of the image from the pole of the mirror is called the image distance. Okay, at whichever distance we will get our image from the pole, then that distance is called our image distance. So in this figure you can take this as a object, so distance from pole P to this is our object distance, whereas distance from pole P to this image is called our image distance. You already know that the distance of the principal focus from the pole is called the focal length. Okay, whether there is a focal point F here, so the distance between F and pole P, this distance is called focal length. There is a relationship between these three quantities given by the Miller formula, which is expressed as this. Okay, this is called the Miller formula. 1 upon v means 1 upon object distance plus 1 upon u, 1 upon image distance is equal to 1 upon f, focal length. This formula is valid in all situations for all spherical mirrors, for all positions of the object. You must use the new Cartesian sign convention while substituting numerical values for u, v, f and r. R is the radius of curvature, which is twice the focal length, in the Miller formula for solving problems. Now there is another formula for magnification. Magnification produced by a spherical mirror gives the relative extent to which the image of an object is magnified with respect to the object size. It is expressed as the ratio of the height of the image to the height of the object. It is usually represented by the letter m. Okay, so letter m is called magnification, and it is the ratio of the height of image divided by height of object. Okay, if we need to take the ratio of image height and object height, image height is this h dash, and object height is this is image height, and this is our object height h. So h dash upon h. Now the magnification m is also related to the object distance u and image distance v. It can be expressed as m equals to, that ratio is this, h dash upon h is equal to minus v upon u, means minus image distance divided by object distance. You may note that the height of the object is taken to be positive as the object is usually placed above the principal axis. ठीक है, हमारा ऑब्जेक्ट होगा वो ऑलवेज अपर साइड होगा, सो प्लस में उसकी हाइट होगी. The height of the image should be taken as positive for virtual images. However, it is to be taken as negative for real images. A negative sign in the value of the magnification indicates that the image is real. A positive sign in the value of the magnification indicates that the image is virtual. Okay, this point you will solve when we solve the sum, so that time you will understand this point. So now let's take one example. A convex mirror used for rear view on automobile has a radius of curvature r. R is 3 meter. Okay, and if a bus is located at 5 meter from this mirror, find the position, nature and size of the image. Okay, so first of all, radius. Okay, radius, you can say it is not a vector quantity which requires any direction, it is scalar quantity. So radius has no sign, whether it is plus or minus, both will be same. For example, this is also our radius of curvature till this, and this is also our radius of curvature till this. So we cannot take this sign as a plus or minus, so always take radius with as a plus sign as of now. Then radius of curvature 3 meter. If a bus is located at a 5 meter from the mirror, bus is 5 meter from the mirror. Okay, that this is our mirror, so bus is located here and the distance of this object is 5 meter. So we have to find v, object distance, first. So our formula is 1 upon v plus 1 upon u is equal to 1 upon f. So here we know v, but we don't know f also, but there is one formula which is r is equal to 2f. So f is equal to r upon 2, so 3 upon 2, which will be 1.5 meter. Okay, so our f is 1.5 meter. Now we know the value of f, so put this value in this equation, and you have to take u as negative. Okay, so this is our formula, 1 upon v plus 1 upon u is equal to 1 upon f. So 1 upon v will be go to the right side, and it will be 1 upon f minus 1 upon u, and that is minus minus, which will be plus. So ultimately we will get V is equal to 1.15 meter and it is plus. Okay, so the image is 1.15 meter at the back of the mirror. This plus sign shows that we will get image somewhat here, okay, or here. It is not specified its height, so it will be erect or inverted, but we know the distance of this image is plus. Okay, due to this plus positive sign, that image will be on the right side of the mirror. Then magnification M. Yes, second thing, you have to find the position, nature and size of the image. So now we have to find the size of the image, so that formula is h dash upon h. Okay, now we have V and U. So by using magnification formula we can find our magnification. So which will be h dash upon h is equal to minus V upon U. So 1.15 divided by 5, so that minus minus will be plus. We will get plus 0.23. So we can say that if magnification is plus, then our image is virtual and erect, and it will be smaller in size by a factor of 0.23. Okay, this we can say that when magnification will be plus. Now you try this sum, or I will solve this sum in the lecture because it requires a live session. Okay, so I can't solve that sum right now. We will solve this sum 10.2 in the lecture. Okay, so we will stop here, and the reflection topic is over here, and next topic we will study, which will be refraction of light. Okay, so see you in the next lecture.